Assalamualaikum warahmatullahi wabarakatuh. Good evening. Let me introduce myself. My name is Fadhil Aldito Putra, 13120-106. Today, I would like to present you the last chapter of Kinematics and Dynamics of Machinery. The topic is about gyroscope. Okay, so first of all, what is a gyroscope? As we can see on the right side of the slide, there is a model of the gyroscope. There consists of the gyroscope frame, and then the spin axis, gimbal, and also there is a rotor. So, in general, gyroscope is a device used to measure or maintain the orientation that works on the principles of angular momentum. And its initial axis of rotation is conserved and consists of a spinning mass on an axle. So, secara garis besar, secara singkatnya, ini adalah sebuah alat di mana yang digunakan untuk mengukur dan mempertahankan orientasinya. Bagaimana cara kerja nanti akan kita bahas nanti. Intinya adalah sebuah alat yang memiliki kestabilannya tersendiri yang berdasarkan prinsip-prinsip dari momentum sudut. Okay, so we can go to the next slide. How do gyroscopes work? So what I've read before, I found that it divided into two. That there's mechanical gyroscope and electronic gyroscope. In the mechanical gyroscope, there's how it works. It depends on the spinning mass that mounted on gimbals, and there is two kinds of the mechanical that I found before. There's a free output and then the fixed output. Maybe we can discuss it later. And then how it works. There are sensors on axis that the function is to detect the rotation, and also there is a precision. And to be in general, there are two basic properties of the gyroscopes. It is rigidity and the precision. The rigidity is the axis of rotation of the gyro wheel tends to remain in fixed direction in space if no force is applied to it. Jadi kira-kira kayak ketika tidak ada diberikan gaya, dia akan tetap kepada arahnya yang udah difikskan dari awal, jadi nggak akan terpengaruh oleh gaya apapun. And the precision that I was mean here, itu the axis of rotation has a tendency to turn at right angle to the direction of an applied force. Intinya ketika dia diberikan suatu gaya, dia akan berputar sesuai dengan derajatnya atau arahnya dari force-nya itu. Nanti bakal ada tampilannya sedikit. And the others, on the other hand, the electronic gyroscope mostly is talking about the vibration and the oscillation. As we can see, there's the Coriolis, and then the proof mass, FAT, and so on. Okay, I think we can go next. Here are the application or the common uses of the gyroscope. There are gyro compass, and then it also used in the telescope, stability assistant. As we know that gyroscope even they are in our electronic devices, such as our phone. So that's why we can play some games. I mean, like that respond to our rotation and others movement of the phone, and also maybe the vlogger or content creator usually use the camera that has its own stabilizer, and also there is gyroscope there that have involved there, and so many things, also missiles and many others. Okay, here I take some calculation from a book, and as we can see here, the precisional angular motion, that we can consider this as shown in figure A, revolving or spinning about the axis OX, and I think we can go further. And here we can get some of the calculation that we got the angular acceleration in the direction of OX. I think we can skip this, and after being limit and neglecting some very small magnitude, and then finally we can get the gyroscopic acceleration, and it is AC is equal to omega d theta per divided by dt. So I think we can go to the next. Here are the gyroscopic couple. As we know that it has takes the 3 dimension. It works and the 3 dimensional. So we can see that the plane of the x, y, and z, and also here the axis of precision, the spin, and also the reactive gyro of couple. And I think we can go to the next. So here, since the angular momentum is vector quantity, therefore it may be represented by the vector OX as shown figure. Okay, I think we can go. Okay, so at last we can find the couple applied to this casing the precision as the equation there on the slide. And we can also see at the right bottom there is a simple schematics that show the relationship between force, torque, momentum, and angular momentum vectors in a rotating system. Okay, I think that's all. Thank you for your attention. I'm sorry if it's a little bit fast because we don't have much time. And here, okay, that's all. Thank you. Goodbye.